Assalamualaikum. So this is our team. First, from Radio 4A, we have Haikal, Razi and Zana. And me, Fatini, from Therapeutic 4B. This is the introduction and the topic that we choose for our mathematics assignment. A recent article by Sina Harian highlighted concern about height and its impact on building structure, safety and student comfort. At KKTM Redang, student height range from 140 cm to 190 cm, which affect the design of dormitories, classroom and accessibility features. Through this mathematical analysis, we aim to study the relationship between height and various factors in KKTM Redang. The result will help improve infrastructure planning, student well-being and the overall learning environment.
Assalamualaikum, I am Razi from R4A. Today I will explain about problem statement for our assignment. Height is influenced by genetics, nutrition and lifestyle, impacting student health well-being. At KKTM Redang, student height range from 140 cm to 190 cm, reflecting variations in physical development. However, with Malaysians stunting rate at 21.8%, concerns arise about non-genetic factors affecting student growth. Additionally, height difference can influence self-confidence and comfort in daily activities. This study aims to analyze the height distribution of KKTM Redang and the contributing factor to better understand its impact on their health and well-being. I will explain about raw data. What is raw data? Raw data refers to unprocessed original data collected from a source. It has not been cleaned, organized or analyzed. It's the starting point for any data analysis. About the raw data from our assignment, the particular data set shown in the image is generated using the raw and between function in Microsoft Excel.
So this slide shows a histogram which represents data in the form of a frequency distribution. On the x-axis, we have the data classes with their lower and upper boundaries, while the y-axis represents the frequency of each class. From the graph, we can see that the mode which is the most frequently occurring value is 147.5. This histogram helps us understand the distribution pattern of the data and identify the most common values. So the next slide, we have an OGIF, also known as a cumulative frequency graph. Here the x-axis still represent the data classes, but the y-axis show the cumulative frequency, which is the running total of frequencies for each class. The OGIF graph allows us to determine key values such as the median, which is found at 50% of the total data, approximately at 160. The OGIF is useful in understanding how data accumulates and in identifying the midpoint of a data set. So in conclusion, about the two graphs, the histogram provides an overview of the frequency distribution of data, while the OGIF help in understanding cumulative frequency. Both techniques play a crucial role in a statistical analysis, especially in identify pattern and trend within a data set.
To calculate the mean, we take the total sum of fs and divide it by the total frequency. Substituting the values, 16,400 divided by 100 equal to 163.5 cm. For the median, we first determine the median class by finding n over 2. N is the total of frequency. Since n is 100, n over 2, 100 divided by 2 equal to 50. Looking at the cumulative frequency column, the first class where the cumulative frequency exceeds 50 is 160 to 169, making it the median class. The median is calculated by the formula median over equal LB plus N divided by 2 minus FB divided by Fn and multiplied by C. To substituting the value, LB is 159.5. Cumulative frequency before the median class is 42. Frequency of the median class is 20 and class width is 10. 159.
Okay, for the mode, the class with the highest frequency is identified as the model class. Using the mode formula, D1 and D2 are derived from the difference between the model class frequency and the previous and next class frequencies. After calculation, the mode is 159.51 cm. For variance and standard deviation, fx power of 2 values are used to compute the total sum fx power of 2. Variance is calculated using the formula omega power of 2 total sum fx power of 2 divide total sum f minus mean power of 2, resulting in a variance of 220.75. The standard deviation omega is then obtained by taking the square root of the variance, giving 14.86.
Based on the mean height value of 163.5 cm, it can be concluded that the average height of individual in the study falls within the expected range. This suggests that the majority of individuals have a height close to this value with some variations. Thus, it is recommended to conduct further analysis to understand the factors influencing height difference within the population. This could help in identifying potential trend or pattern related to height distribution.